Let me also welcome you to our workshop, where we would like to show you a convenient way to do 3D simulation in a React application. We switch. Yeah, to demonstrate this for you, we will build this flight data visualization application. All right, and the tech we are going to use today is a library called React 3 Fiber. As you may know, to display 3D graphics in the browser, you need to use the HTML canvas. And this React 3 Fiber library is an abstraction over the Canvas API, which allows for building 3D scenes in a declarative way or in a React way, if you may. As you will see, this little library makes it convenient to do things from displaying basic meshes like boxes to custom meshes to applying materials to these meshes to adding lighting to a scene to applying interactions over these objects. Okay, that's about the technology. The repository we are going to work today. We have given you some tools to make it easier to follow the workshop. If you get lost at any point, you can consult the README, which contains a transcript, a rough transcript of the workshop. Also, the workshop itself is broken down into steps. And with this yarn get x script, you can apply the changes in a certain step to your code. But be aware, your changes will be stashed and the code will be applied over it. Also, if you want to fast forward to a further step, let's say step 5, and you have done the coding up until step 2, you will need to apply the in-between steps in sequence. Yes, we also have a shared Pastebin to help you out with. If you need help, you can post code there. Also, the README contains code snippets you can use. And if we can't fit into the time, as I said, the repository contains each step of the workshop. Also, it contains the end product on the master branch. Yes, if you have questions, raise your hand, make a noise, and we will try to answer them.
So, please do check out the Git repository. I hope that you already have it. I will assume this from now on, and if you're not having it, I will just give you one more minute while I explain the rest. What we have given you in this repository is basically a few pre-built components to the whole application that we're trying to build that are not really relevant to today's lesson. So like I took over and did the maths for you and then shoved it into some sort of utility functions, so we don't have to go into the depth of the 3D mathematics. What we also have is a generator that's going to generate us some data for today. And in the public folder, we will see some models that I have downloaded from sketchfab.com. This is a place where you can find free models for your own use, so long as you appropriate the licenses that go with it. Okay, so the operational things that I already have said is that there is this yarn command, or Levi has said, and there is this yarn command that you can use. Yarn get 1, 2, 3, 4, whichever step you want to get or cherry pick to your branch. Make sure to either commit your changes before this or stash it, but this script will stash it for you anyway. And I will also be using this README file to copy some code snippets from it. If it comes to that, mostly I'll try to type it out, but I will be typing fast. So if you cannot catch up, or if you feel that your application is not working, but you still want to follow through, do use some of these snippets from here, okay? What else? Okay, I think by now everyone has it. I think all of us should be in the workshop start branch, and we can jump and get going. But we'll be typing a bunch. I definitely will type a bunch. So let's do a small exercise first. So left hand up if you know React, and right hand up if you know 3D mathematics and graphics. It's a bunch of left hands, but there's a right hand. Cool. Yeah, okay, so I think the convenience of this library is that you can mostly use your React knowledge, and you don't really have to know a lot of 3D. You will have to inevitably fight a bit with maths and the concepts of 3D, but I'll try to explain some things as we go along. If something is super weird, something is not, I don't know, understandable, ask. Levi is also here to help. He will probably know the answer too. So let's jump to step 1. What I haven't done yet is I haven't installed the dependencies because I wanted to highlight what sort of dependencies are we going to add. So in the README file, you'll find a list of dependencies that we're going to add. And you can also run these commands to get Yarn going, and I will be talking in the meantime. So there's 2 sets of dependencies. 3 is the JavaScript library that's going to do this abstraction over the 3D rendering, basically, and the interactions over the Canvas's WebGL API. So normally when you would be programming the Canvas on the web, it's a very inconvenient API. You would struggle a lot with it. But what they did with 3 is they provide a bunch of great APIs to operate and work on this API. So this is our foremost library. The second foremost is, if this is even a word, React 3. React 3 is the library that's going to connect these 2 magical worlds. You'll be able to use React-like syntax in JSX with this 3D world. So we'll be writing almost as if we were writing HTML into our code, and 3D objects will appear. React 3 has a supplementary library, Dry. This is just a bunch of utilities that we can be using later. And there is this GLTF JSX, which is a library that's going to help us import models into our application. So now that all the dependencies are installed, we can actually start the application and see what's happening. Yarn start will run the dev server in the background, and I hope my port is not used. And we can just keep running this in the background. It will rebuild your application as you change it. I think if you use VS Code, you'll have to save first, and it will rebuild it. Otherwise, you'll find your application on port 3000 in the browser. OK, let's try to inspect what we have in here. So first, the entry point is the index.tsx. This file only contains basically a reference to the flight visualization app file. Within this file, and I'll shrink this down here. Within this file, we basically have 2 divs. And we have this capital C canvas. This is not the HTML canvas, but you can see this is a canvas from React 3. This canvas is basically the magic door into this context of 3D rendering. Within this object, we can use expressions that will only work if you use React 3. Currently, what we're seeing is a white screen, but this is exactly what we're supposed to be seeing. There's nothing else here but an empty blank canvas. So, if we start working our way through, we can just test out, do a hello world-like application in this world. I have a bunch of help for myself, so I won't get lost. So let's put a few items into this world. Let's start with a box. Box is a utility that I created, so you have to import it from our own /utilities. This box is going to be, as the name says, a box. Let's just see how this works. Oops, something appeared. It's already half success for me. So let's do a few more things. There is an object called orbit controls. Orbit controls comes from Dry, the utility kit that I mentioned. This utility is going to help you interact with the canvas with like the normal motions that you're used to. You can drag the screen and then something will start rotating. So after this, well, this should start rotating. Maybe a refresh helps. And this will happen every now and then that we'll have to refresh the screen. So we have this black box in here. Cool. Let's go. Let's add some lights to the scene. And when I say scene, what I refer to is anything within this canvas object. And we'll do an abstraction for this very soon. Let's add, like, for example, a type of light, an ambient light. Ambient light means that everything is lit with the same intensity at the same time. It's not like sun that it comes from one spot, but it's as if everything was glowing radioactively. On this object, we need to set some sort of intensity. 1.4 is just good enough, I guess. And now we have something that's lit. Okay, and let's add the color to this box. Whenever you will see color in React 3, you can use the standard HTML colors that you all know and love. My new favorite is hot pink these days. It's a cool name, but you can use whatever you know. So this is a cool pink box that's rotating now. Yeah, so we can improve this a bit, and that's going to come in handy later on. Let's change this ambient light to a point light. Point light is quite like the sun, but it comes from one exact point. We can also set an intensity on this. But in here, we also need to define a position. And you will see most examples coming up with positions will require 3 numbers. Because we are in a 3D world, we'll have X, Y, and Z coordinates. For this, I usually use my right hand. You can all use your right hands for this because this is a right-handed system. Your thumb is going to be the positive X. Your index or pointing finger, index finger, is going to be the Y positive. And then this middle finger is going to be the Z positive direction. Everything else is a negative, so my finger snapped backwards would be the negative Z. So let's place this to, let's say, 2, 2, 2. I'm all for 2s. Now you can see that the light is coming from this exact angle up to the right, 2, 2, 2, and it's only lighting one part of the box. You can see that as I rotate the box, the lighting doesn't change. Is because the whole world is at the stationary place. As we have placed it into 0 and the light is next to it, what we're doing is we are rotating around this scene. So this orbit controls gives us this floating camera that we can rotate around. Okay. I hope you can still follow. I'm going to demonstrate one interesting thing, but first let me put this into an object. So as I said, I call this thing a scene, and let's use it like that. So let's name this thing like the flight visualization, or like the flights scene. I do this a bunch. I don't know if you do this often when you code, but I already write out stuff or type out stuff that doesn't exist. So let's create a folder called, let's say, flight scene, and put a new TSX file in it. Flight scene TSX. And in this file, we'll have this default export for the flight scene. And this works just like React does. You can use these empty open close tags for fragments. That just means basically a bunch of React elements or React components that I want to render when I do render this flight scene. And don't forget to import it. All right. So once again, I've just moved everything into this scene so that now when we go into the scene and we see something that's within the scene, that's already within our magical world where all of this React 3 things are already functional and working. Normally, you wouldn't be able to type out orbit controls or box or point light in your React code. But here you can. It's provided by React 3 Fiber as implicit, okay? You don't have to import this thing because it's available because you're inside of that canvas. And here we are. My application is still rendering. It's still pink as it was. And to have this hello world complete, I want to show one more concept. And this is going to be the concept of animation and grabbing references to objects in this 3D world, because it wouldn't be so cool if we couldn't animate anything around here. So let's try to animate something. Let's try to animate the intensity of this light. You can go the very hacky way. You can use like a use effect and put a simple set interval in it. Right, so I hope I don't really have to explain it, but use effect in the React hooks world is something that only executes once you render this component, so long as the dependencies don't change. And don't forget to put this empty array in here so that you declare that you don't have dependencies. They should only run once. We set up this interval for like every 1 second. We want to change the intensity for this light. And how would we normally change stuff in here? Well, you would use a state in React. Is the font size okay, or should I increase it? Back row? Cool. So let's introduce a new state variable with like useState, as we already know. And this is going to be of type number. So here comes TypeScript's help, is that it's going to help you with typing your variables. Let's start with like intensity 0. Set intensity. This is just all boilerplate. And in here, we will set intensity to, let's say, 10 might be too much, but a number between 0 and 5. Every 1 second, we will change this, and we will channel this variable from the state into here. Save the application if you're in VS Code. I don't need to. As you can see, this is changing all around. Every 1 second, the color is changing. So we're already animating something. But this is not really the way that they intended for you to use React 3. Because it's not very performant, especially not with you handling your own intervals. You would be really having a hard time trying to somehow do 60 FPS with this smooth animations and stuff. So, well, we can keep this in here. It's not going to hurt anyone. But the way they actually recommend you to work with 3D objects is through this hook that they introduced, is called UseFrame. So UseFrame is a hook in which your callback function is going to be called about 60 times a second. So you can get very good frame rates and good animation times with this, and it's very performant. So in the UseFrame, unfortunately, you shouldn't be setting state. You can imagine that if you set a React state 60 times a second, it will just crash your computer because it's going to burn a hole into the CPU. What they recommend is you get a reference to this object and change it in a raw way, just like you would change stuff in JavaScript. So let's get a reference to that object. And for that, we can use useRef. So we'll call this lightRef as a reference to light. useRef. And in here, we often have to declare the type of object that we're working with so that TypeScript will know what sort of properties are available. So this is a point light. The type of it is with capitals, unlike the object itself. And here now we can use lightRef, current, and if we have it, then we can change its position. LightRef, current, position, I don't know, set X. This is not going to be super great, but this is going to be good for the purpose. So let's set all three coordinates just for the heck of it. Okay, if you still follow, now we set up a very frequently running animation in which 60 times a second might be a bit too much, we will set the position of the light. So, oh, one thing I forgot, this ref actually needs to go and be handed into this object. Okay, so we create this reference, we give it to this object, and this object will set the current variable on it, and you can retain that in your hook, and then you can animate based on that here. Something. Don't get dizzy from this. All right, could you follow? If not, here comes your trick. You can say yarn get 1, and it will stash your current changes and get the first state. And you can continue from then on out. It's more or less this, I think. Okay, I think I talked about everything. So now we're going to step 2. Okay, so if you have missed this part, then yarn get 1 will get you here. Any questions so far? Okay, so in the second step, what we're going to do is bring out some of the models that I downloaded for you. So models, you can inspect this and you can check out these files in public. The fact that they're in the public folder, that means that the already set up create React app server will serve these items under the root of the application. So like /data/airports would get you to this file. You don't have it yet, but you will eventually. But /models/globe/globe_gltf will get you this file. So this gltf format that you can download or use from Sketchfab is basically a JSON descriptor file that describes models and how they connect to the shape of the object, which is referred to as meshes. And hang on. Mesh is the composite of geometries and materials. Okay, so geometry is the shape of the object, and God damn it. So materials are the skin on it. Okay. Well, we will see it soon. But this file is connecting these. It has a bunch of description, but basically it points to this file cmbin. This contains the model for the globe that we're going to be using, and the textures for the globe are in these files right next to them. And this gltf file connects them. So as I show in the README file, you can copy these instructions again, either with yarn or with npx. You can run these commands. What they will do is they will generate a wrapper for these gltf files in a TSX format, so you can use these in your application code. We'll inspect them in a second. If you're using Windows, then you'll probably have to replace the slashes to backslashes. Okay, so I pointed to these files. I generated 2 new files. Since I was in the root of the project, they live now next to my package.json. Let's create a folder and call it models, and place these files into that. So with my screen size, I will not be able to grab it unless, here we go. So let's move them into this folder called models, and we'll have to do some adjustment in post. Again, if you get lost, don't panic. You can still catch up with get2 once we finish with this state. So you can see that there is a bunch of junk generated in these files. Let's look at globe, for example. This contains a lot of nested structures and everything, but basically what this is trying to extract the data from the gltf descriptor file that contains a bunch of different things. We will not need all of these, so try to follow me when I clean this up. I will basically retain one of the groups, the outmost group, and then start deleting everything until I hit the first mesh. The mesh needs to be preserved, but like all these encapsulating groups can be removed. except for one. Why am I doing this, you can ask? Well, those parts were not really needed. Those were added by the modeler person who were modeling this, and maybe they needed it. We will remodel it. We will set up some other properties for it. And we retain the outmost group so that, as you can see, the generated code generates some props propagation. It propagates the props into this group. So if I change, let's say, the position X on this model, it will change the position X on this group. And group, you can think about groups like you would think divs in your HTML code. This is basically just like something that holds a bunch of contents together. And this mesh is what I mentioned. Mesh is basically an objects model. It contains a geometry, which is the shape of that object. For us, we have this earth geometry, and we have a material on it, which is the skin on it. Okay, unfortunately, this will still not work because the generator didn't know where our file was. So it has like incorrect references for path, and this is what we have to correct. I would like to extract this into a constant. You can use your ID for this, like extract constant, introduce constant, or you can just manually do it and call this path to model. Maybe manually doing this is going to be just the way I will go, but and I can use this in another place here because it's referenced twice. Okay, and the actual path, as I said, since this is living in public, it will start with slash, then models, then globe. So slash models, globe, globe GLTF, WTF. Okay. And if I start using this object in my scene, so let's go to the scene where we have this strobing light. Maybe let's tell this light to chill out for a second, and let's add the model for the globe. So my ID is smart enough to find this file so long as actually it's super smart. It can find it just because of the file name, but it will help if you name your function globe in here. But otherwise, just do an import manually. So I did this globe. What we now have is a box, a globe, and no light. Let's see. Oops. Cool. So what is this? We are inside of the Earth. Luckily, you can zoom back and you can still check out the model. It's huge. But this was basically a few lines of code after you copied out all the magic from the README. So constants actually has a few parameters that I pre-calculated. I think it's suggested that we scale down the globe by 20 so that our initial camera will already see the globe in its whole, and we wouldn't be inside of it. We wouldn't have to zoom outside. So you can apply the scaling on top of this group somewhere, or you can scale this mesh also. Probably this would be the best place. So this group that contains this object, if we scale the containing group, whatever is inside of it is also going to get scaled. Scale, globe scale. This is, divide by 20. So we divide the globe's size by 20. If I refresh, whoa, it's already here. It's small, it's approachable. And I think it's also centered. Okay, so this is half success. We have a model for a plane as well. Let's try to trim that up too. So the plane is going to be a bit more difficult. The model that I found was a bit trashy. It has a lot of, actually not so many weird things, but it's really not positioned right. I'll tell you that. Let's remove the unnecessary groups. Again, let's maintain, in this case, I would say let's maintain 2 of the groups because we'll need to do some adjustments to its position. So we maintain the outer group, again, for propagating the props into it. It will catch everything that you set from the outside. And this group will get our properties, but let's check out what happens if I just import the plane like this. Okay. I extract this to constant, path to model. Oh, no need for extra. Okay. And we also need to correct this. It's models plane / plane gltf. And in the scene, maybe this is going to be faster now, plane. Yeah, this is the tricky part. Plane also means, a flat surface. So maybe let's rename this to airplane later. But for just testing, oops, we have it. So it's somewhere. You can see the size of it is also not so great. Position also not so great. Once again, I have kind of pre-calculated how much we should scale it down to be fitting, but you can use your own stuff. If you feel like you would like to see bigger planes on your globe, I don't know, divide only by 200. Okay, we'll go in the plane, and we will also apply the scaling on this group, right? No, maybe on this group.
Trial and error.
Yeah, we'll trial and error. And on the inner group, as I said, this is not really positioned right. So also position should be plane, root node position, and rotation should be plane, root node, rotation. These are the things that I mentioned that I did for you, so you don't have to deal with it. The way I dealt with it is I created a component. It's just an HTML, a bunch of sliders that I was sliding until I rotated the flight to the right place, and then I took note of the numbers, and then I put them into constants. So now we can use these numbers with the airplane. So let's hope and pray that we will see that flight somewhere. I just reloaded because here we have it. So the flight is here inside of the box. Maybe we'll not need the box anymore, but at least it's here. Okay. And maybe one more thing to make it nice, we can position. Oh no, I think it's fine here. Let's remove this box and let's keep the point light at 222. But I would suggest let's remove this strobing animation. We don't want to get sick or dizzy from that now. Intensity, let's keep it at 2. Okay. And if I reload again, we have some light, and the flight is here. So as you can see, there's no occlusion. The Earth's surface is not going to remove the light. It's not going to put shadow on the flight. If you really want, you can work that out. You will find examples for that in the list of examples. But here, I think we'll be just fine with this. Okay. And I didn't check my notes. I hope I didn't screw something up.
Very good.
Cool. So this is the end of the second step. Can you more or less keep up if you want to? Okay, just another exercise. Who wants to keep up? Right hand. Who's trying to at least keep up? Okay, and who can keep up? Left hand too? Okay, sweet. But this is your chance again. You will have a lot of things on your stash, but let me also do this because I don't want to trick you. So yarn get 2 should get me to a state. Ooh.
Yeah.
That's what I'm dealing with as well.
What happened then?
Well, that should be normal, no?
Flight scene deleted. Well, maybe.
Yeah, it's Git magic, so.
Okay, so if you want to resolve, actually, I think it's because we created a new file, but so the trick is going to be git reset. I'll go back to the initial state. I'm not supposed to have anything bad in here. You can also do this if you're lost. I removed these things. I think what happened is that we have created files with different names, but again, yarn get2 should get me to the,
Also yarn get one
oh yeah, you should start with yarn get1 first.
in sequence.
Okay, so yarn get1, yarn get2. Okay, so this is how you can catch up. Now at second state, I think the example that I created was a bit smarter. What I did also in here is that the flight is or the light is orbiting the Earth, but that should be just an added bonus. And we should have the flight still in the middle. Okay. All right, so yeah, we're starting step 3 now. And just a small detour, like we'll do this like very 3D and very game-like thing, whereas we said data visualization. This is going to be data visualization, but I think this example is just a bit more fit for showcasing the concepts in React 3 and showcasing the concepts in Three.js. If you want to visualize very basic charts, you can imagine how you can scale a box to fit your charting needs if you want to do charts or that sort of data visualization. But this is also visual, and we're also going to have some data on it. So we're on step 2, we're going to step 3. So what we're going to do is utilize some of this animation basics that we have seen with the strobing lights, and we will utilize it to make our flight go around the plane or the Earth. And what I like to do is introduce a bunch of levels of abstraction. So I don't want to hack the animation code into the plane, however, it probably would work. I like to introduce new files for new concepts, and the airplane TSX is going to be the concept, or actually I think I called it flight so as not to get confused with the other thing. I'll call this flight. This is going to be the concept of a model that actually does fly. It's not just rendered somewhere, it does fly. So what we do in this is basically we just proxy to the other object. We just proxy to this plane in flight. And it would be enough if I just replace the previous call to flight in here. And if there's no errors, it's going to render the same way. And what's wrong? Okay. And now I will task this thing with the magic property of flying. So what we'll need to do is the way we are doing the flying is we're not going to tell them, hey, go to this specific XYZ position. What we're going to do is, here's the globe. We're going to move the flight on top of the north pole, and then we're just going to rotate the group that contains this flight. So if you displace the flight compared to its origin, compared to its 0 position, and you start rotating its containing group, then it will rotate as if it was attached to that with a pole. So let's create groups around this. As I said, groups are quite the equivalent of divs. You know, in HTML rendering, it works more or less the same way. If your text is within a div and you move that div, then the text moves with it. And we will need another group. So this group is going to be the displacement. We will use this group to move the flight up to the North Pole. And we will use another group for rotating this in some fashion. This does not add anything to the rendering, like it doesn't render anything extra if you have groups. And this group should have the position y. Position y should be, actually we have this in the constants again. So I'm not sure if this will work, but let's give it a shot. Earth surface height is basically, we know how big is the model more or less, 42, and then we scaled down that by 20. So the Earth's surface is 42 times 1/20th. But we can use this constant and hope that it will work. So if we import this, then this should mean that the flight appears on the North Pole. And here it is. It looks a bit weird. Something is off, for sure. Well, maybe just add a bit more to this. Maybe float height. We have a constant that's just like a small number that we can further displace it so it's not within the models but on top of the globe. Okay? Cool. So flight is now up top. As I said, this is the first step. This is the inner group. The outer group we're going to use to rotate this thing. So as I said, animations are happening with UseFrame. Oh. And we need to get a reference to this group. And we're going to call this rotation group. UseRef. The type of this is a group. And in here, if we have this group, then well, let's see what TypeScript offers to us. Rotation group current dot. Well, we can change this rotation object, but there are these nice functions. Rotate X, rotate Z, rotate on axis. That looks interesting. You have also seen Quaternions. This will come up very soon. Let's try this. Rotate on axis. And what do we need to do? So we have this, as I said, right-handed system. X, Y, Z. We need a vector or an axis that's either pointing to the right or the left because we want it to go around that. So I also have constants for this. Left is basically a vector that's pointing to left because positive x is the thumb to the right, so negative x is left. And every animation, let's rotate this by a very small amount. I don't know, 0.1. And I also missed this. The reference was not passed to the group. I always miss this. Oh. Speedy. Now this is just because the number 0.01, 60 times a second, is a lot of rotation. So what we can make use of, and I will introduce a new concept in here, is that in this callback, actually, if you have assistance, you can make use of two variables, state and delta. Delta will tell you how much time has passed since the last render, and state will give access to the Three.js state. Three.js state is basically the abstract model of your world. It contains, well, you can look into it, what's in it. TypeScript is going to help. There's like clock, there is the whole scene, there's a camera. If you want to hack around with this, you can also try that. Don't expect good things. If you change the properties of the camera, maybe you will see some weird stuff. So I will introduce the concept of a phase. I like to use phases. I don't know how to translate this to Hungarian. What this is going to be is a variable that contains basically a number between 0 and 1. This is representing the completeness of a certain animation. At 0, it's at 0%. At 1, it's 100%. And it's good because if you put your animation into a phase state of 0 to 1, then you can map that out to anything. So if you want to animate that something that is moving 2 to the left and 2 to the right, you got to go and create your phase variable that goes from 0 to 1, and then you can double it. And then now it goes from 0 to 2. And then you subtract 2, and then you double again, and you have -2 to plus, something like this. So enough blabber. How do we do something that periodically goes from 0 to 1 and then back to 0 to 1? What I like to use in here is we have access to the clock. And on the clock, we have this variable elapsed time. This will just go up. This is the amount of seconds that has passed ever since you started the application. And there is the modulo operator in JavaScript. This is, the remainder. Let's take the remainder of 4 and then divide by 4. And I'll explain this in a second. So this is just going up, and we'll take the remainder of 4, 4-es maradék, and then you divide it by 4. So you have this number that goes up from 0 to 4 all the time, because as the number goes up, your remainder is always going to be limited to 4. And then if you divide that by 0, then your phase is going to go up from 0 to 1 continuously. And now I can use this for doing great stuff. So let's replace this rotation. And I can just leave it here in a comment. How do I do that? So the reason why this is not so great is because for these periodic motions that I want to do, is just flying around the Earth, is not super great, because I would need to calculate how much should I move in every step, and contain, like, knowing how big a step is, how much should I always move. Why don't I do something different? I could say, I have this number going from 0 to 1 all the time. Let's map that to rotations that would go from 0 to 360 degrees. Right? So, and then when we finish, we go to 0 again, and then we have this number that goes from 0 to 360. That's a full rotation, so we can start again. I can probably do this. Let's give it a shot. Rotation group, current. Ooh.
A quick question.
Yep.
So 4 is because of 4 seconds? So
yes.
The cycle is 4 seconds?
For me now it's 4. You can pick whatever number you like, but yes, this number that we will put into these expressions, we will have a bunch of these. This is always a cycle time. Okay. Good question, thank you. And you have to keep in mind that this is in seconds. Normally what I would do in JavaScript applications is date.now. This is in milliseconds, so you would have to divide this by, you have to modulo this by 4,000 and divide by 4,000, so you get a cycle of 4 seconds. In here, cycle of 4 seconds is like this. So let's try to rotation x, set x. Well, let's give this a shot, and we'll see. So, no, this is not going to work. Rotation.
Want me to pull up the code?
No, I know the code actually, but I just wanted to try out something new, but I'll go vanilla. So you could do this, right? You can try to figure out what is the amount of rotation that I need to apply, since we can map this phase into degrees. But I will introduce one more concept here, is the Quaternions. Quaternions in 3D mathematics are a concept. It's basically a 4-number set. It's almost like 3D coordinates, x, y, z, but there is another coordinate as well. And they're used for describing rotations in 3D space. The reason why they are great is because normally you wouldn't be able to do consecutive rotations around the same or different angles and get the results that you want. Because if you rotate something to the right, then all of your coordinate system is going to get rotated. So if you rotate something again by the x-axis, your rotation is going to be fucked up. Sorry. So, but then quaternions, you can multiply them. It's awesome. You do one quaternion for rotating this way, and then you do one for rotating this way. You multiply them, and then you get the result as you expect. Rotate this, and then you're there. So how do we do, and how do we work with quaternions? It's less spooky than it sounds. So you create a new quaternion by new quaternion. It's a tool. It's an item that comes from 3. And what you can do with this, on this, you can set from axis an angle. It's exactly almost like the previous one. It's just not incremental, right? Rotate on axis changes the current rotation and then moves it along. But this one says, okay, based on an angle or like a vector, what is the current rotation that we want? So into here, we can map our phase. And this is now rotating between 0 and 1. We can check out what this will look like, and we will correct it afterwards. So now we have the Q, the rotation quaternion, and let's set the rotation group's rotation by that. So current set from quaternion. And we will do this quite a few times, and I think if you will ever work with 3D spaces, you'll have to know these things, so you're welcome. So what's happening is we have this number going from 0 to 1 over 4 seconds, but then it only goes until here. It's because 1 in radians is not a full circle. So if you remember some of your high school maths, radians are the things, you know, that are related to pi. And for a full rotation, you need 2 pi's worth of radians. So this is how you map, like 2 radians are 360 degrees, 2 pi radians. 1 pi radian is just half a circle. So this thing is awesome. Now we map the number that goes from 0 to 1 into a number that goes from 0 to 2 pi, and that will result a full circle. And again, I think we are done with this step. Yes. Cool. I know this is a lot, but I hope that you can at least pay attention and watch. And then now, again, is your chance to join back. I will also do this because I don't want to leave you in the dirt. So this thing that I just worked out is going to be stashed when I say yarn get 3, because we are going to the end of the state 3. We have gotten 1 and 2. Poof. So we have more or less that in here, but we'll remove this anyway. It's a bit more complicated way of explaining how to go full circle by going 2 half circles. And yeah, if I look at the example, I think it should do the same thing. I hope I didn't screw it up. Yeah. Okay. In the example that I worked with, actually in this commit, I probably changed the color of the flight so that even when it's dark on the other side of the globe, you can still see the flight loud and clear. Okay, so continuing from step 3. Step 4 is going to be, we're going to map out geo-coordinates, latitude and longitude, into positions on this rotational world that we have created. And we will use 2 great cities for this, Sydney and Budapest. Actually, you can also use this README to grab some of the code examples. I forgot that. So for that, we'll need to generate some data. We provided you with a data generator that you can call with yarn. And this is generating files under public/data. These are just like big JSON files containing latitude and longitude coordinates for the certain cities and flights in between these cities. And let me close up a few things. Do you have any questions for now, or is there something that's not working? Because if the yarn thing didn't work, you should have called it out earlier. But
will you publish the final version in Git?
It's already there, yes. In the master branch, if you switch to that, you get the final version, but don't do that yet. We're working on it. So what we want to do in here is now translate these latitude and longitude coordinates into placement on this rotational world. So we were working with this flight in here. And I will comment this out because I think this is not needed for now. So we're back in the flight. What we want to do is we want to place this flight into somewhere. So let's take a property for which city should this flight be in. Let's call this city for now, city of type I airport. And once we have the city, we have properties on that, latitude and longitude. Cool. How would you do this? Like, how would you go about mapping out your latitudes and longitudes? Well, you look at what they actually mean, and they're basically angles of rotation around the globe, but one of them is actually shifted by 90 degrees or so. So one of them is going from 0 to 180, and the other guy is going from, I think, 0 to minus and plus 90 degrees. But I have done this calculation once again for you. In the utilities, you can find this function, rotation quaternion for coordinates. But it's no cheating in here. You can see we're using this quaternion thing that we used previously. we rotate around the left angle by the latitude, and here is the 90-degree shift. And we are rotating around the up angle, or the up vector, by the longitude coordinate. And we basically multiply these two rotations. And this is what I said. It's so easy. We rotate with two angles, and then the end result is going to be how you would imagine they would rotate one after another. So let's use this function, rotation quaternion from coordinates. Let's feed in what we have from the city.latitude, city.longitude. And then the resulting quaternion we can use for placing our flight. Once again, there is this rotation quaternion, or rotation box, or the reference for that. And on that, you can call this set rotation from quaternion. And we need to pass the city in to this flight. So I'm working my way backwards. I hope it's not that confusing. I could have done it the other way. So we will need the city to be passed in here. But how do we acquire Sydney? And how do we acquire Budapest? Now for that, we will have to load the data. And we can load the data in this file. We can do it in another file. Maybe this is the most convenient. So it's going to be just as simple as you would do in your normal application. Since this is React, you can use this use effect. Make sure to put this array in here. I don't even know why this is not a default. And use the simple fetch. So once again, if you want to grab something that's hosted in public, then /data/airports. And then the fetch API is such that you gotta call this JSON function on the object, and afterwards, in the third then, you can get your airports data. And what you can do with this is you can store it in a state variable again. So let's say airports list. And the type for this is a list of I airports. I hope I didn't mess it up. And now in this state variable, we can find our Sydney and Budapest. Let's find an element where the element's ID is SID. And let's find one where the element's ID is Bud. Cool. TypeScript is not happy because find might not return a result. So normally I would check whether these exist, but I can just be assertive with TypeScript and say, trust me, these will exist because I know the data. And this is passed down, and we use it to create a rotation. Hopefully, if the application didn't crash yet, when I refresh, it did crash. And I think this could be because the data might not be loaded at some of the time. So I actually have to be a bit more cautious and say, let's only render this flight if Sydney exists. Again, this is React as you know it. If Sydney, then add this flight, conditionally render it. Same for Budapest. OK. And there is a flight atop of Budapest, and there is a flight atop of Sydney. Okay, we're halfway there. This is not all of it yet. So what we can also do is we can try to animate these flights in between. And another magical property of Quaternions is that you can interpolate the states in between. So I would say, OK, here's this rotation and down in Sydney. Here's this rotation up in Budapest. I'll tell you that I'm, I don't know, halfway through, then find out what is the rotation that corresponds to halfway there. So for that, again, let's do this the forward way. So let's go from Sydney to Budapest. And from Budapest to Sydney. We will fly 2 charter flights, and again, TypeScript is not very happy. I mean, not just yet, but eventually it will be unhappy that we didn't confirm that both of these do exist at the time when we want to render this. So Sydney and Budapest exist. Budapest and Sydney exist. I know I can save some lines of code if I do. I'll not be smart. Okay, let's adjust the properties in this flight object. So we said that we want the from and a to, and these are going to be airport references. From and to, 2 properties, and the way we animate in between is we need to, again, come up with a phase variable. Let's again do it with this state clock elapsed time. Let's take the module of, let's say, 5 seconds and divide by 5. So now this variable is going to run from 0 to 1. And the way to do this interpolation for quaternions, also not that difficult, but quite weird at first. So you create one quaternion, new quaternion. And then into that, there's this function called slurp. And slurp is the interpolation function. You give it the end state and the start state. So like from to and then how far along are you in that animation. So it exactly expects this variable that runs between 0 and 1. So at 0, this will be only from. At 1, this is going to be the to. So we just need to calculate the from and the to quaternions, and that goes exactly like it did earlier. Rotation quaternion for coordinates from. And do this for the to as well. Okay, so we created 2 rotation quaternions that correspond to the 2 rotations on the 2 places on the globe. And with this function, we will interpolate between them, and it will set the variable's value basically by just calling it. You don't need to use the return values. Actually, if you use the return values, that's incorrect. So something might be happening because it's frozen. Maybe there you go. They're flying. It looks as if they're bouncing back and forth. The truth is not that they're bouncing, but they're running both on the 5-second period. So whenever one of them arrives here, then they switch places and they do the same animation again. Good? And maybe in this step we can actually correct this. So this looks a bit weird, right? That they're looking upwards and they're flying, but we never programmed it to look in the way. We're just rotating them in weird ways. So we can make use of another utility that comes with Three.js. So if you have an object, you have a reference to an object or a group, and I do have a reference to the flights container. This is the group that we moved to the North Pole. If you have a reference to this container, you can get the world position of it. So at a certain moment, before I actually rotate it to the next state, I will ask, okay, where are you in the world? And put it into a variable. World position, before animation. So this would like give me the previous place of that flight. And I just, why are you unhappy? Maybe this is not current yet. Aha. Oh yeah, so some of the APIs in Three.js actually work in the way that you need to create an object like a vector and into which it will be able to load data because it wants to reserve a bunch of memory. So if you want to reuse vectors and reuse objects, then you can do this. So okay, let's load into this vector the world position, and we can call this world position before. And after the animation has happened, after we have moved just one gradual movement towards Budapest, let's say, we can tell the flight container box or group to look at the previous position. Sounds a bit weird that why would you look at the previous position? Oh. But the way we set this models up is that we set up the airplane to look into the negative Z direction. So that's why actually everything is just flipped on the other side. So if I tell the flight to look backwards, it will look forward, appearing to us. It was a smart move. So this is like a lot of these question marks are here because my IDE is smart enough to know that this object might not be there. But at this point, let's actually ensure that those objects are there. What's the other one? Rotation box. So this small if is just going to ensure that we only animate if these are already present because the references are not immediate. Keeps freezing all the time. Okay, so I think it's almost there. At least they're now looking the right direction. But what happens is this look at doesn't preserve the Z rotation. So when you look at something, it will screw up your Z rotation. Your camera or your object is going to be a bit tilted. So you can do some very basic correction on it. You can say rotation Z should be 0. And I think this will help more or less. Oh, yep. So this one is flying upside down. This guy is flying the right way up. So once again, I have done a bunch of heuristics at home, just trying out different cases. And in the utilities, I have this function that we can use for correctly guessing based on the positions and the directions. What should we set this Z rotation to so that it looks the right way? And this requires the from and the to parameters. And voila. So now they're looking the right way. And we have these two flights going between the two cities. Again, this might be very useful if you're animating stuff and your animation is not looking the right way. You can use a bunch of these tech functions that come with Three.js. And this is more or less applicable for any sort of 3D application visualization you want to utilize. Quaternions is also very great for rotation, I think, in all of the contexts and not only in games or simulations. And this was the end of 4. Any questions? Are we running until 8 or a bit later than that?
Plus 8.
Mm-hmm.
8?
8:30.
Okay.
Yeah.
So bear with me. Next up, we will add cities to the game. You can, or not the game, the simulation. So you can again get the 4th state to catch up with us, or you can continue from where you left off if you have been successfully following. So to load the cities, we basically need to duplicate this data loading just to save some time. I think it's called airports. So there is another JSON containing data for airports. No, we already have that. Flights. Yeah. So what we're doing in this step, sorry, I was incorrect. What we will do is we will render a bunch of flights. Now we have the actual data. We will visualize the flights in between the generated data points. If you know how to grab this data online, there is a bunch of repositories of actual current flight data. We just generated some based on that. We'll need another state container for that. And let's call that flights list. And do the same thing in here. It's flights data and set. Okay, if all goes right, then we have a bunch of flight data now in this variable. And another magic of React that I really like is the array expansion that you can do in here. So you can say, for all of the flights, let's map them out and add the new flight object for each one of them, right? So flight, and the question is, how do we obtain the cities that they go to? Because on the flight object, we only have the IDs. And that's not enough, so we need to find the cities that correspond to those IDs. We can either find them with like .find that we did in the previous, or we can be a bit smarter and create another object that's basically a lookup. So airports map or object, so it's going to be a lookup. Map is not the geological or geographical map, but it's an object that's keyed with a string, and it contains airports. Okay, so this is a casual JavaScript object. It will contain IDs as keys, and it will contain airports as values. And in this map, you can look up by ID. So you can say flight.id, and it will find, actually not the flight.id, but the arrival airport ID and the departure airport ID. So this is the this is the to city, and this is the from city. And we just pass this along to the object, right? And as it's usually in React, you're recommended to give a key, and we can use the flight's ID as a key. Okay. One thing that I did not do yet, so we don't populate this map yet. The way to do it is you can write your own like reduce on the list. What you would do is you create an object and collect all of the entries into it, but Ramda has a very nice function, index by. And index by, you give it a function that selects the key. What should I use as the key in the object? So for every element, use the element's ID, and you just give it a list. And it will create an object that contains all the elements of this, keyed by the ID. Airports data. And it's because this is not typed yet. Here, now it's going to be fine. And we can put this into our state variable. Okay?
A question. Use effect runs once, only
Yes.
once?
Yes.
And then afterwards everything runs over this frame stuff, set frame or something.
Set frame is not in this place. We don't use it in here.
Oh.
So use effect in React is basically running as many times as you want, actually, but then with these dependencies, you can say that I don't have dependencies that can trigger a rerun for me. If I used to forget this all the time, so I kept downloading the same JSON over and over, and that fried my computer, but now I know that you need to put this in here, so this only runs once. So this segment can be used for like downloading data or getting data, loading stuff. And yes, that's also true. This is an effect that runs asynchronously, so this part of the code will only execute after this file is downloaded. So there is going to be a point in time when maybe flights are loaded, but airports are not yet. So let's also guarantee that airports exist at this time. Or if they don't exist, if there is no airport, well, there will be an airport, but if actually, by the time that the list is going to be populated, the map is going to be populated. So what I'll do is I'll check for the list to have elements. So airports list length is bigger than 0. And only then will we try to render a flight. Otherwise, don't render anything. This is to prevent, again, a race condition when you would have flights, but you don't have airports yet. And when you look it up from the map, you will not find the to and from city. And it's a mess, but it's a coordinated mess, right? Everything happens beautifully. It's because all of the phases that we picked were on 5 seconds. So every 5 seconds, everything will just meet at their destination, and then the animation restarts. I don't know what sort of computers you have. I usually like to just limit this a bit further down. Like a simple slice. I think just showing 10 flights should be enough. Okay, this is good enough. So now this is now some sort of real data visualization. We fetch some data from the internet or from our own hosting. We transformed it in a way, and then now we're visualizing it as flying airplanes. Yes, and I think I didn't want to do anything else in this state. Yes. One more thing that I would change before we move on to the next stage is that the flights data, if you look at it in the JSON, it contains the timestamps as strings. And JSON.parse, or like this JSON parsing function, doesn't actually parse them out to proper data objects. So it's going to be hard to work with. So before we store them, I would suggest let's transform them in a way that we properly parse those dates out. So when you actually, I created another utility for this, parse flight dates. So you get like a flight, and then you parse the flight dates on that flight. This is basically just using all the fields from that object, except for these 2 times, but it will actually parse it into data objects, so it will be useful for us. Again, this is not happy because we didn't declare that these are flights. And this is the end of step 5. How are you holding up? I know I'm typing fast, but that's why we did the exercise in the beginning. I had both of my hands up. It's easy for me. All right. Again, I'll give a few minutes now if you want to catch up and go to get 5 or like catch up with 5. The next step what we are going to do is visualize these airports also on the map. It can be useful for just another, I don't know, like placing something in 3D space, but also we will showcase interactivity with the cities. So if I want to proceed from here, let's just close this up because I have very little room on the screen. So we can use the same array expansion like we did for flights. We can expand all the airports. Airports list, map. Here is one airport. And again, I'm doing this a bit backwards. I will map these into airports, airport components that don't yet exist. But I will create this object very soon. And let's add the key on it. I know that airport objects have IDs. OK. So what should an airport look like? Also, I create this in the scene because this is a React 3 object or concept. We call this airport. Oh, we can put whatever we want in here. I will go super basic in here and just render it as a box that we used in the very first example. If I import it from the right place again, let's use our own. And what we take as a parameter, as a property, is an airport of type iAirport. And what we know about this is this should behave more or less the same way. So I will do it, or I will treat it just like I treated with the flight. I create a group around it, so I will be able to move it on top of the globe, and then I'll be able to rotate it. So let's have one for the positioning, and let's have one for rotation. And this will have the rotation eventually. And what I need to do is I need to get a reference for this. Use rotation box ref. That's how I called it, I think, the other one. Use ref. This is a group. And let's pass this in here and import group. And the position of the city, again, this is the displacement from 0, 0 on top of the Earth's surface. This was something like 0 to the x, globe or Earth surface height plus flight elevation. Maybe we don't need that. Let's try just this, and then 0 again for the z coordinate because we want only upwards. And how do we rotate this box? Just like the other way or the other time, we create a quaternion for rotation with this function, rotation quaternion for coordinates, because we also have the coordinate data for the cities, latitude and airport longitude. This is the same model exactly. We use the latitude and longitude to get a rotation descriptor and then apply that on the rotation box. But again, only do this if this reference exists already. Okay, so what we did is, again, moved the city up to the top and then rotated it so that it will actually be where the city was. If my computer doesn't freeze, I need to import this because I forgot. Ooh.
Cool.
Now this is pretty realistic, actually. Cities are now all over the world, but I guess you can sense what's happening in here. This box, by default, without any parameters, is just way too big. Let's set the size on it to 0.01, maybe. I think this is 3 coordinate or 3 sizes on like the 3 directions. X, Y, Z size. Either that or they're inside of the globe. No, oh, no, those are flights. Okay. Well, let's try then 0.1, maybe 1/10. This is good enough. I guess the exact details will be better when we just catch up with the original code that I posted. Okay, what else can we do in here? So what I wanted to showcase is the interactivity with these objects. And if you look into the implementation of Box, this is basically, as I said, is just a model that contains some geometry of how it should look. And it's basically just a square-shaped, if you use a box geometry, it's going to be a square-shaped object. And the standard material, we just pass along the color that you set on it. I almost forgot. Now better. So that's only this. But then inside of it, we also have this variable reference. I call this reference because otherwise React is going to be crying at me that I pass a reference by a different name or by the name ref, and it's not a forward ref. So what we can do is we can get a reference to the city, which is going to be a reference to the group, and pass it along to basically this box that we used. And on this city reference, we can set, actually, did I want to do this? I can probably do this as well. Let's try it out. So I have now a reference to this object, which means I can access fields and properties on it. So I could hook something like on click, no. Sorry, I got a bit sidetracked. So what you can actually do is on the mesh, there are properties like on pointer out and on pointer over. So these are the properties that get actually propagated just because we spread everything that we pass along to it. And I ran these out through the box. So actually we don't need to play around with references or passing functions in. We don't need this for now, but we can already use these on pointer out and on pointer over events in here. And basically just store whether we are hovering into a state variable. And it's going to be a Boolean type. And we do is when the pointer leaves, then set hovered is false. And when the pointer enters, set hovered is true. Okay, this is getting ugly. Now it's a bit more readable. Normally, you would not operate with your own abstraction, so you wouldn't have to propagate these events, or it would look a bit different. But if you declare meshes or maybe even groups, you would have these functions. And there is like on pointer down, all of these events are now available because React 3 has mapped the interactions with the virtual model into your API over the objects. Okay, so now in the state variable we have is hovered, and let's change the color to something also nice. What's your favorite color, Levi?
Blue.
Just simple blue. Okay, let's switch it. So if I hover, then it's blue. I don't know why it's a bit pinkish. I think that's maybe our perception, but it seems that hovering seems to work. Cool. To make it a bit more interesting, maybe we can add the point light that's only rendered when hovered. So if hovered, then point light with an intensity of, let's say, 2. I don't think I need anything else. And maybe a color. And this is also always going to be blue. Okay, so when there is dark in here, this might work actually. Maybe just the positioning is not quite right. Actually, it is lighting. We just don't have dark enough in the globe. You can see that the sides of the other squares are getting blue because of this. Maybe if I just elevate this a bit higher, so like position Y should be a bit higher than the normal position, maybe 0.1 higher.
Yeah.
Good enough. Let's try maybe red. You can now see a bit better. I think the blue planet doesn't react well to blue colors, but you can see a slight color change just because we're hovering. And one more great thing that I wanted to showcase in here, I hope you're still attentive at least somewhat, So there is another great thing that the React 3 developers created for us. This tag is called HTML, and it actually is with React Dry. And with HTML, you can actually include any sort of HTML in your 3D world, and it's going to follow the objects where they are. So let's create a div with, I created this class InfoBubble that just contains some backdrops, so it's not transparent. So anything that I write in here, let's say I want to write the airport's city's name into this. Then on hover, this will show up. And it's tracking the place, so it's pretty cool. So with this, you can do interactivity. You can place in links into the content. Let's say you visualize a piece of shoe, and then you can put something like this on the shoelace, and then you can link to the shoelace separately. And if I don't remove these just for a second, this will stick here, and I can show you that if you inspect this, you will see that it's not trickery, it's not rendering weird stuff. This is actual divs with 3D transformation on it. So if I rotate the globe, the transformation changes. So it tracks the position on the globe. So it's stuck to basically that component that I put onto. Let's put this back. And we can move to step 7 if we still have time. Great. Any questions?
I have the question like, how many polygons do you have on this scene now?
I didn't count.
I mean, hundreds, thousands, or 10,000?
I honestly don't know. Maybe you can inspect some of the stats of 3. The reason why I don't really know it is because I'm working with models. And I would need to know how many polygons this model has. And it's in a binary format, so I don't know.
Okay.
But maybe if we check out the original source for these models, it's generated actually, I think you can find the link somewhere in here. Maybe this Sketchfab link will give you like a rough idea about how many polygons were used for that model, and then you can multiply it up with like how many flights you're visualizing. Okay, so in the 7th step, we're going to do another bridging between the two worlds. So this is also going to be another React-ish step. What we are going to do is we will bring in a filtering component that you can use just like you would do with like type-in filters or select filters for filtering to flights, and only render some of those flights. And this is another big piece that I pre-wrote so that we don't have to deal with it. Again, if you want to catch up, then you need to do yarn get 6. So I made a very ugly and very horrible like table-based filtering thing. But I think this is good enough for the purpose. We can add this into the flight visualization app. But this thing needs to go outside of the canvas. I can show you what happens if you put this inside of the canvas. Or I could actually show you, but it's exactly this. That my table would be snapped with the map, and it would rotate around, and it would be not placed where I want to. So I go back outside of the magic realm of React 3, and I add the controls next to here. So let's create like a div for it. And let's use this filter controls. And now we already have a bunch of properties that we need to fill out. So filter controls, flights, airports. Oh, we're already in trouble because we don't have access to that. So that's why I said like maybe it would be actually a better place to load this data and manage this data outside of the realm of React 3. Let's keep this React 3 inside of Canvas for visualizing stuff. And let's keep the data in a common place, way outside in the application. I just moved all of this state and the loading of it to outside. Now we can share this with the controls as well as the scene. We just need to pass these few variables back. So let's call it again flights list. And airports list. Oh. Okay, these are not existent. Maybe this can help me. Nope. So let's add all of these properties again for prettiness. Maybe let's call this type flight scene props. And what we are taking is an airports list. So the type for this in TypeScript is quite clumsy, right? But I created another helper type for this, a dictionary of iAirports. And this is just a shorthand for anything that has string keys and contains this generic type. And flights list, which is a iFlight list. And we can pick these variables up in this object spread or here. And I think my scene should work if there is nothing red. Oh yeah, these are all red. But now we can finally pass all the things in. I was a bit clumsy with the naming, but this is flights list. This is airports list. This is airports map. Simulation time. This will be a parameter that we would create in the last step if we get to that in 20 minutes. So let's just create a variable for the current timestamp and pass that in as a constant. Let's always get stuck to that date time. How many flights do we want to render? This will be something that we manage later on, but let's limit to 5 or 10. The selected flight is null, and let's not create these handlers just yet. And this is actually a handler that we can use to, anything that changes within this control will update through this handler. So this is your way of communicating out your filtering results after the filtering has changed to this outside world. So we need to introduce another state variable for that. Let's say flights filtered. State, and we know that this is going to be a list of flights. It starts with empty. And so if the filtering changes and we get a different list of flights, then we set the flights to that. I think this should be fine. And then we use this filtered versions of the flights to be passed to the scene. So this way, I'll try to explain this again. The whole complete flights list and airports list and everything goes into this control. Whenever you change any of the sliders or any of the filtering, then it will communicate the result through this onFiltering changed event handler. You set the state to here, and now you propagate this filtered version of the flight state into the flight scene. And this is now getting close to the demo that we showed in the beginning. If this ever loads, maybe there is a build error. No. This has happened to me before. This happens when, good. This happens when either this runs way too many times, or maybe the control is not so great. No. Simulation time doesn't change. So we could do some debugging now. I don't know how to debug applications that freeze because of overload. We can try to figure out what's going wrong. So what's happened probably is that we just re-render it way too many times. I probably used the wrong variable, so I triggered an infinite loop in some fashion. So if you guys are following along, let me know what I did wrong. But we can try to, again, guess.
Something is wrong with the set field flights filter.
Uh-huh.
If you remove that code, then it works. Probably that is called Quaternions.
Yes, good. Thank you. Let's see how this works without it first. Thank you. Yeah, so the cities are still there. Flights are not. So I think I missed something with the name. So set flights list. Flights filtered. Maybe just the ordering for this is not quite right, so let's move everything up. I don't think this should really matter, but flights list. Okay, let's check this now. Is it still freezing? Embarrassing. What could we change with this? So, filtering changed. Aha, I have a guess. I think I was again clumsy with the naming. But no, flights is a list of flights. This is a list of airports. Well, if
I think airport map is in plural in the other file.
S is missing, yeah. I've seen that too.
Airport
map, yeah.
that shouldn't matter. TypeScript should let me know if something is wrong. So this is the way I take the properties in this file.
Your issue is that the function that you pass is you create an every render. So if you just pass the function that is returned by mistake, that's immutable.
Nice. This? Right. That could be a... Thank you. And as soon as the data loads, if I didn't mess something else up. Yeah, but now the flights are not present, I think. Gagger, is it working for you, right? Or I might have typed something else again incorrectly. Because as soon as my flights are loading or... Oof. And I think I got the error as well. Well, lucky for us that... Lucky for us, we can always jump to the end of this state and then just show our ways backwards. But I think, yeah. Yeah, I think that's what I'll do because I don't want to waste our time and we have 10 more minutes left. So let's suppose I got lost with my own code and just fast forward to, what was the last one that I, git log. I checked out step 3, so I need to fast forward from there. Yarn get 4. And then we are at the supposed end of yarn, or the 7th step. Code will look more or less like this. We pass everything to the flight scene, and then now we have selection enabled as well. So let's suppose that I didn't screw up the code somehow. The data shows up, and the filtering now works. As soon as you update the filter, it will only render that one flight that goes there. And we also implemented selection. That's also a very much Reacty thing, is that we passed in a function that can be triggered when you click something on the table that we rendered. So let's say there is an onClick event handler here, and we set the selected flight to that selected flight, and we bubble this selection out to the shared context, and then we maintain the selected flight, and we send that into the flight scene as well. And based on this selection, we also pass this down to some of the flights. If they are selected, based on this selection, we can highlight and render some information on the flights. So this also contains a bunch more lights and stuff, but it still works fine. One more thing that's not working yet, and that would be the 8th step. And also that's actually a bit more difficult to implement, but if we have 10 minutes, then I'll rush over it. Is someone still following besides Gergő and you? Okay, cool. We'll rush, and then if you have been following so far, maybe you'll be able to actually catch these last bits. So now we have this filtering option in here, very Reacty. We propagate that into the world. Selection is working also, but something is not quite right. And this may be not a thing for many data visualization applications, but the time is not really actually current. So what happens is we're just rendering all of the flights within 5 seconds, right? The time to go to Budapest or from Oslo is not the same to go to Hong Kong. So we need to somehow invent a global simulation time, and we have to propagate this down to all of the flights so that they would all know how far along are they in their flight. So for this, we'll introduce another trick. Maybe this is the first trick only. What we will need to do is set up a control for controlling the speed of the simulation so that we are not stuck at 822, but we will be able to speed it up so we can fast forward how the flights are going. I created another simulation control for this. It's a simulation speed control with the examples. And again, let's try to maintain the state that we get from here. Simulation in a state variable. Let's start at, let's say, 1. The way I created this control is that it will just use like the powers of 10. So as you move this control, the simulation speed is going to go from 10 up to 1,000. And the one thing that we need to conceptualize in here is that I have shown you that in the canvas, within the context of the canvas, in any of the, let's find one, any of the use frames, you get a reference to the state where you could be using the clock, and you could be checking what is the elapsed time of the simulation so far. The problem with this is actually counting real seconds in human time, so you will not really be able to push this forward faster. What you can also not do is you cannot just propagate down the simulation speed and say, okay, if 10 seconds has passed, then let's multiply everything by 1,000, and 10,000 seconds has passed. But you kind of have to maintain your accumulated time. Like in the beginning of the simulation, you will only count like normal time, but afterwards you speed it up to 10 and then 100, and then you have to just add it for yourself. So something that's not coming conveniently or easily in in this React world is working with global states and global objects. So you kind of have to cheat your way in a React frame to do some unsafe operations on an object, because we know that this state object is passed to all of the UseFrame hooks. So on this object, on the clock, we can actually set like a simulation time, or what I call in the notes hacked world time, or hacked time. And this TypeScript is not happy about it, because this object obviously don't have this property just yet. But if we fight our way around React or TypeScript, then we can use anything. And now this is better. Now, if we know the simulation speed, then, which is going to be a number, then on any tick, on any re-render of this hook, we can get the delta. We get, okay, 0.7 seconds has passed, and we accumulate it for ourselves. And we times it by the simulation speed, if this is defined, right? But then we can do something like this. Hack time should be again, I call this hack time because we do some unsafe type operations here. There's no actual hacking involved, unfortunately. So we either create this if this time doesn't exist yet, and if it does, then we increment it by our sped up simulation. And we can now reach this variable in any of the use frames. It's quite convenient. So in the flight, I would be able to just get this variable, simulation time, and use this for calculating my phase. So what we did for this phase so far is that we said, okay, let's say that it flies in 4 seconds, and let's get the module of that, the total elapsed time, and then somehow create a phase variable from this. Now what we need to do is, how do we calculate this new phase? So it needs to go again from 0 to 1 as the start time happens, and we go towards the end time. Luckily, the flight contains these two variables. So flight dot arrival time is when it's supposed to arrive, and then flight dot departure time is when it's supposed to fly off. If you convert both of these to numbers, and then you subtract them from each other, so arrival is the later one, so if we subtract the earlier one, then we get the total flight time in milliseconds. Okay, so this is our period time now. This is what was the 4 seconds. And we need to translate this into seconds because these are milliseconds, so let's just multiply this with 1,000. No, actually, divide by 1,000. So this is the total flight time. And how do we calculate the phase from that? So we need to know how far along are we in this flight. So we need to get the current time, which was this simulation time, and basically subtract that from the departure time, I think. Now I'm getting very confused, but luckily again I have notes. Global time. Here we go. I was smart enough because I knew I would fall into this. If we can check the utilities, there is a magical function that will actually calculate this phase somehow. No, turns out I wasn't. Okay, so let's calculate the phase then. It goes like this. We need a departure time. Are we on the clock? We are. Okay, let me use some camera magic again. Here. 8.1, 8.2, I think is the very end. Yeah, I forgot /1, but it still works. Okay, sorry, I had to fast forward because I think our time is up. Sorry for being so slow. Yeah, I think if we just check out the simulation now, I didn't actually lie, it did what I explained it would do. If we change the simulation speed, the time will be updated a bit faster. So now you can use these filters for like only rendering flights that are present or just rendering all of the flights. And if you speed up the simulation further, you'll get faster flights and even faster flights. Okay, I think this was it. Thank you so much for trying to tag along.